So we have done the over and under approximation before. Those also could be referred to as left hand and right hand sums. You know, the over or under was if they were above or below our curve. But if you think about, okay, so we did something like this, right? And we used our little rectangles. So if I based my rectangle on these heights, before we called this the under approximation, right? And it was under because all of these rectangles are under the curve. If I wanted to add this up, do you think that would be a left or a right hand sum?
Right.
For each rectangle, am I using the left hand side of the rectangle or the right hand side?
The left.
The left. So basically for the left hand sum, you start with the leftmost point. The right hand sum, what do you think I would do?
Probably overestimate.
It would be the overestimate in this case. You would be using the right hand side of these rectangles. Well, even more accurate than that would be what's called the midpoint, where you use the height in the middle of each of these rectangles. Okay, so we can do left, right, or middle. Out of the three, which one do you think is probably the best? The middle is probably going to be your most accurate representation. So that's all that is. Let's actually try it. Yes, sir. All right, so I want to do the Riemann sum for f of x equals x cubed minus 6x, where my midpoints are on the interval 0 to 3 with 6 rectangles. Okay, so we start out our change in x, same as always. We're ending at 3, starting at 0, dividing it by 6, so my change in x is 1/2, or 0.5. Right? We are starting at 0, so I'm just going to draw a really rough sketch here.
Oh, we're n is 6 now. Okay, got it.
So if we are going to estimate this, we're adding up 6 things. The width of all of these will be 0.5. And so basically we just have to add up all of our heights, right? And we get those heights by plugging numbers in to the equation. So think about this. We're starting at 0. My change in x is 0.5. If I asked you for a left-hand sum, what would be the first x value you plug in? 0. If I asked you for the right-hand sum, what would be the first x you plug in? 0.5. If I ask for the midpoint, the middle of this is 0.25. So I'm going to start by plugging in 0.25. 0.25 cubed minus 6 times 0.25. Now, once you have the first one, you can get all the others, because how much does my x increase each time? 0.5. So the next one I plug in 0.75. Add 0.5, so we get 1.25. 1.75. 2.25. And 2.75. Notice that is the last point inside my interval. Okay, it's smaller than 3. If I added 0.5 again, it would be 3.25. That's outside my interval. So do you guys all see where I got the numbers I plugged in? So now it's just pushing buttons on our calculator and seeing what we get. And this is maybe even easier, talking about left and right hand sums might be even easier than over and under approximation, because You don't have to think about if it's above or below your graph.
So they always be doing the most up in that class. Every single day. Never in my life have I taken the least.
Plug that in. No, I never got a negative before. Why would I have a negative now? What does that mean?
Because we're under.
Yeah, it's below the axis. All right, let's look at this one. So this time, I'm kind of jumping back to the problems from yesterday. It's the same function for 0 to 3. The midpoint was used to approximate it. So we're giving our best guess to be negative 7.03125. Let's see how close we are. Let's find the actual thing. So we did these yesterday. Change in x. To find the exact, change in x is the same way, except we don't know how many rectangles. So it's 3 minus 0 over n, or just 3 over n. X sub I is our starting point, which was 0, plus the change in x times I. So we get 3 over n I. Alright, so this was the same as our last test, but it's just written differently. We talked about it yesterday. This integral is the same thing as saying the limit as n goes to infinity of the sum from 1 to n. And then for our function, we replace these x's with our 3 over n I. So that would be 3 over n I cubed minus 6 times 3 over n I. And what do I replace my dx with? So times 3 over n. So if we start multiplying this stuff, 3 cubed is 27. I'm going to go ahead and multiply this by the 3 over n. 81 over n to the 4th I cubed minus 54 over n squared I. You guys with me there?
Yep.
So now we do with the summation formula. So when we do the formulas, that's when the summation goes away. So we have 81 over n to the 4th. What is the I cubed formula?
N squared plus, or times n plus 1 squared over 4.
Minus 54 over n squared. The I formula is n times n plus 1 over 2. So now we have all of our simplifying. The amount of work you show here is kind of up to you. We can cancel 2 of these. N plus 1 squared. So 54 divided by 2 is 27. So we get 81 n squared over 4 n squared. So 81 over 4 plus 162 n over 4 n squared. So 81 over 2 n plus minus 27 n over n. So minus 27 minus 27 over n. And now we're in good shape because anything with an n on the bottom goes to 0. So we get 81 over 4 plus 0 minus 27, which is what? So our approximation wasn't perfect, but it wasn't horrible either. Is this okay? So we did a lot of these yesterday, but I just want to do one again today to remind you. We'll do one more midpoint and then give you guys time to work. Oh, making fun of me?
No, never.
You got that? So the last one for today. Use the midpoint rule with n equals 5 to approximate this interval. So, change in x. What's my change in x going to be? Yep.
1.
Or if it's easier, that would be 0.2. All right. So we know we're going to be multiplying everything by 0.2, and we're going to get 5 things. I'm using the midpoint rule here, so I'm not asking you to do the actual interval itself. So think about this. This interval starts at 1, and we're going to go up by 0.2. So where does the next one start? 1.2. So if I asked you to do a left-hand sum, what would be the first number you plugged in? 1. If I asked for a right-hand sum, the first number you plugged in would be 1.2. If I want the midpoint, that's the middle, or the average. So add them up, divide by 2, what do you get? So the first number I plug in will be 1.1. And then you just add your change in x to get every additional number. So plus 0.2, so the next number is 1.3, 1.5, 1.7, and 1.9. And notice my interval should end at 2, and we did end before 2. And I got 0.6919. Is that okay?
This is literally the first one that I got the right answer.
Well, the last one you had all set up right. You just skipped one. Okay. So you've got time to work on that handout from yesterday.
Staring into the abyss, so I didn't stare at Bo because I very nearly made a joke